time I studied this 10 centimeter wide heatsink, which consists of 10 fins separated by a space of 37.8 millimeters. The height of the heatsink is 25 millimeters. I used the same arrangement for the LEDs, the 50-watt COB LEDs, which are separated by a distance of 6.6 centimeter, located at the middle of the width of the heatsink. This is a photo of the two fans that I used. The first one is a 20 CFM fan, the second one a 40 CFM fan, and as you can see, the heatsink is floating by using some strings that are attached to a PVC base. This is in order to avoid the heat transference from the metal to another object through air, which actually it can affect the temperature measurements by various degrees. These are the thermal images, and I will return to this later. And this is an image of the lamp while functioning. Both LEDs are working at this time. So as I said, I used two 50-watt LEDs, COB, which means that they are directly connected to AC. The temperature measurement for the 20 CFM fan at an ambient temperature of 22.5 degrees centigrade is 58.3 for the zone A and 58.1 for zone B, which is this location and this location for zone B. And for the 40 CFM fan, the temperature is lower. At an ambient temperature of 24.5 degrees is 44 and 43.9 for zone B. So a greater airflow implies a lower temperature, as was obtained for the 8.7 centimeter heatsink in the last video. An interesting comparison is that these temperatures are higher for this heatsink in comparison with the 8.7 centimeter wide heatsink, which is this one. This is the 8.7 centimeter wide. As you can see, the fins are taller in comparison with the other model, and in average the difference is about 4 degrees. This is for the 20 CFM fan, and this is the difference for the 40 CFM fan. This is an interesting result because a lot of clients tell me that the base width is extremely important for dissipating more heat. However, in my experience, this is mostly true for transient phenomena, not for phenomena that reach an equilibrium state after several hours of working, like LED lighting. So in this case, it seems that the fin height is much more important than the width of the base. Finally, the difference between the thermal images obtained by the thermal camera and by the thermocouple were 6 degrees for the 20 CFM fan and 4.4 degrees for the 40 CFM fan. And this is a behavior that is almost always seen, that the temperature measured by the thermal camera is higher than that measured by the thermocouple by this amount at around this uh, these certain temperatures. I'm sorry. I'm sorry. These messages are distracting me. So that's it for this week.